Hello, and today we're going to learn how to solve rational inequalities. This is different than solving rational equations. The process is different. In this process, we're going to set one side of the inequality equal to 0, and then we're going to combine everything on the other side into a single rational expression. After we do that, we're going to find the intercepts and the restrictions of that rational expression to use in a sign test. You're going to see how that all plays out very shortly. Alright, so let's look at this inequality. First we have to set one side equal to 0. I'm going to do that by adding 1 to both sides. So I'm going to get 1 over x minus 3 plus 1 is less than or equal to 0. Okay? We need to make this into one rational expression, which means we need to change 1 so that it's something over x minus 3. Well, it'd be x minus 3 over x minus 3. So 1 plus x minus 3 all divided by x minus 3 is less than or equal to 0. And let's just clean up that top. We're going to add the 1 and the negative 3, so we're going to get x minus 2 over x minus 3 is less than or equal to 0. Okay, let's figure out what our restrictions are. So restrictions on this expression. Our denominator can't equal 0, so x cannot equal 3. For the x-intercepts, we would need to set our numerator equal to 0, so x minus 2 is equal to 0, which means this thing crosses the x-axis at x equals 2. Okay, both of these values are going to be important, the restrictions and the x-intercepts. Now we're going to use the sign test. So we're going to create a horizontal line representing all the values of x. X cannot be 3, so at 3 we're going to put a circle because this is a hole in all of the values of x's that we can use. And when x is 2, the function is equal to 0. It's an x-intercept, which means the y value is 0 there. Alright, we want to know where the function is less than or equal to 0. Well, it's going to be equal to 0 at the x-intercept, so 2 is definitely one of the solutions. But what happens in between 2, 3, and all the numbers on the outside? We're going to choose one value in between and on the outside of each of these, and that'll tell us whether it's positive or negative if it satisfies this condition. Okay, so let's start with 0. 0 is an easy one. So 0 would fall right here. If we substituted 0 in for x, we get negative 2 divided by negative 3, which is positive 2/3. So everything on the left side of the intercept of 2 is positive. Let's pick a number in between 2 and 3, something like 2.5. 2.5 minus 2 is 0.5, which is a positive number. 2.5 minus 3 is negative 0.5, which is a negative number, which means everything between 2 and 3 is below the x-axis, or negative. Okay, now all the numbers on the outside of 3, where the hole in the domain exists. Something like 4. 4 minus 2 is 2, and 4 minus 3 is 1. So that's a positive over a positive, which means everything on this side of this hole in the domain is positive. So here's what your graph kind of looks like. Everything on the left side of this x-intercept is positive. Everything on the between this intercept and this kind of hole in the domain is negative. And then on the other side of this domain restriction, everything's positive. We're trying to satisfy where everything is less than or equal to 0. That would be everything that's negative. It's equal to 0 here, it's not equal to 0 here, and everything in between is less than 0. What we can say then is at 2, it's equal to 0, which is part of the solution. All the way up to 3, it's less than 0, and then at 3 there is no value that we can use. So in interval notation, these are all of the values of x that are would make this expression less than or equal to 0, and consequently would satisfy the original inequality. Okay? We're going to look at one more, a little bit more complicated. Doesn't look complicated at first, but it will be. Alright, so remember, we can't just multiply both sides by x because we don't know if x is positive or negative, meaning we don't know if that's going to flip this sign or not. So we can't solve it the same way we would solve equations. We're going to have to subtract x from both sides, so we can do that. Greater than 0. We're going to have to create a common denominator. To do that, we would have to multiply this by x and then divide it by x as well. So it's going to get x squared over x. So 1 minus x squared divided by x is greater than 0. This is a difference of squares, so let's factor it, and you'll see why in a second. Over x is greater than 0. Okay, let's look at what our restrictions are. So the restrictions on this function is that my denominator can't be 0, which means that x cannot be equal to 0. So this is going to be one of the important points. Let's look at the x-intercepts. X-intercepts are where my numerator is equal to 0. Well, I have two factors, so if 1 minus x is equal to 0, then x is equal to 1, that's one x-intercept. If 1 plus x is equal to 0, then x is equal to negative 1. That's another x-intercept. So I have 3 points that are important. 1 restriction, 2 x-intercepts. So when I do my number line here, I'm going to have 3 different points. 1 at 0, and it's not an actually inclusive number, so we're going to put a hole there. 1 at negative 1. And 1 at positive 1. And these are x-intercepts. They actually exist on the function, so I'm putting them as dotted lines. These are actual x values we can use. Okay, we need to test all these intervals in between and on the outsides of the intercepts and the restrictions. So let's do that. Let's pick a number like negative 2. I'm going to plug it into this equation because it makes life easier. So choosing negative 2, we did negative 2 squared, which is 4. 1 minus 4 is negative 3, so it's a negative on the top. And substituting in negative 2 in the denominator gives me a negative in the denominator. So this whole side is a negative divided by a negative. It's all above the x-axis. Then it hits our x-intercept. Now what happens in between negative 1 and 0? Let's choose something like negative 1/2. Negative 1/2 squared is 1/4. 1 minus a fourth is 3/4. That's a positive number. Negative 1/2 substituted into the denominator is a negative number. Positive divided by a negative. Everything in between here is negative. Alright, let's substitute a value between 0 and 1. Positive 1/2. 1/2 squared is 1/4. 1 minus 1/4 is 3/4. That's a positive number. And divide it by 1/2. 1/2 is also a positive number. So we have a positive divided by a positive. That ends up being positive. Everything between 0 and 1 is above the x-axis. And then a number on the outside of 1, something like 2. 2 squared is 4. 1 minus 4 is negative 3. It's a negative number. And then 2 in the denominator would be positive 2. So negative divided by positive is negative. So there's our sign for this function. Now, we're trying to figure out where this expression is greater than 0, meaning above the x-axis, not including 0, which means we do not include our x-intercepts. So we're only looking where it's positive. It's positive from negative infinity up to negative 1. And it's also positive between 0 and 1. So here are all of the x values that would satisfy this inequality and therefore satisfy this inequality as well. Any number between negative infinity to negative 1 would make this statement true, and any number between 0 and 1 would make this statement true. Remember, that's non-inclusive of negative 1, 0, and 1, because this is a greater than, not a greater than, or equal to. Okay? And that is the strategy for solving rational inequalities.